Hi, everyone. I hope you hear me well and you see me well. First of all, thank you for attending this online Adevinta meetup this afternoon. Today we will talk about artificial intelligence and machine learning, and we will talk about how it helps us to improve our products and our processes. So I hope you enjoy the talks. Today I have with me Carmen Herrero, who is lead data scientist at Mango. And she's also a good friend, and I would like to thank her for being here, well, being at her house but connected, because as soon as I suggested her to do this session, she was eager to do it. So thank you very much, Carmen. And well, this afternoon, after some words about Adevinta, that is the host of this online meetup, Carmen will do her talk about machine learning in Mango. Then I will do my part about deep learning in InfoJobs. And we have a surprise at the end. Xavier Roca, the third guy in the left, will speak about Data for Good Barcelona briefly, 5-10 minutes, to present the organization. Data for Good Barcelona is a non-profit organization dealing with data scientists and social projects, and he will speak a bit about it. Okay, so I'll just introduce you Adevinta in case you don't know the company. Yes, Adevinta is the biggest marketplace specialist in Europe, and our goal is to find a new purpose for everything and for everyone. So that's why we work in different marketplaces, supporting local communities and also working for building a more sustainable future. We are present in all these countries you can see here. And in Spain, in particular, we have these marketplaces. We have coches.net and motos.net, also Fotocasa and Habitaclia for real estate as a real estate portals, Mil Anuncios and Vivo, and also InfoJobs, that it's the main job board in Spain, is where I am working right now. So the project that I will explain to you is related with InfoJobs. And just a final message is we are always looking for talent. So if you are a talented person and you want to join our team, please contact me or another person in Adevinta, and we will be very happy to speak with you and see how we can collaborate together. So having said that, it's time for starting our first talk of the evening, and Carmen Herrero will start now. Yes.
Okay, so now it's my turn.
Yes, the screen is yours.
Thank you so much, Didac. I'm very, very happy to be speaking here today with you. First of all, I'd like to thank Adevinta and especially you, Didac, for inviting me. I think it's a great opportunity to stay together and stay connected in these difficult times that we are living. And I think it's very important to keep our mission of growing the community and help others, inspire others. So I'm actually stoked. And today, it's a machine learning approach that we have developed at Mango to optimize prices during the clearance sales. But let me introduce myself first, because normally you will, see me and you'll be able to see, to feel a little bit more about me. And as now we are on a virtual meetup, I will talk a little bit more about me that I normally do. So I'm a mom. I'm a mom of a beautiful, lovely 3-year-old daughter. Of course, I'm not biased at all, but she's the most beautiful girl in the world. I love photography. It's my big passion. I'm a physicist, where I studied in the Autonomous University of Barcelona with Didac quite a few years ago, like 20. So yeah, we go back on time. I do hold an MSc, a PhD in physical oceanography. That's where I started my career as a researcher. And then I realized I wanted to have an actual and real impact. And that's why I decided to move from the academia to the private sector. I've been a data scientist for the past 4 years and something, where I really feel that I can have an impact and I can bring value to organizations. Having said that, all of this means that I've been working on long time series for the past 10 years, and I've been doing predictive modeling for almost that time. I'm going to share with you some of the knowledge that I have gained on this time, and also all the tips and tools that I think will be useful for you if you are doing data science nowadays. So the contents of the talk. I will do a very brief, I promise, introduction of Mango. Let me just, one sec. I think it's not working, is it? Oh yeah, sorry, it is. Sorry. I will briefly introduce also who are we, the advanced analytics unit of Mango, and what is our mission. In retail, we have an immense and whole universe of data. And I will speak a little bit more about that and what I think are the most important properties of a project in data science when you have a lot of data. I will present our use case, the Markdown optimization project that we have done during the sales season, the past 3 sales seasons actually. And I will conclude with the tools and tips that I think will be useful for the data scientists out there. So basically, it's what have we learned in this time, and I will conclude with some final remarks. So Mango, I'm pretty sure you all know the brand. There's no very big introduction that I have to do, but just to put some numbers and give you some context, Mango is a pretty big company. We have 2 billion euros turnover in 2019. We are present in a lot of countries. Basically, 77% of our business is international. That means that we have shops on more than 100 countries, 115, and we are present in more than 80 countries with an online shop. Also, for us, it's very important, our core values, and that means that we are trying to be more sustainable. So right now, 44% of our fibers are from natural origin. We design at our headquarters in Palau Solità, here in Barcelona, 18,000 garments for a year. So it's basically 6,000 garments per season. So we have 2 seasons during the year. So we have a fast retailer. Having said that, that means that we have a ton of data to work with. Our data teams are organized in 3 different points. The most classic one is the information. It's a data engineering team. It's the classic, they are building the classic products of maintaining the data warehouse, doing some reporting and analysis, etc. Then we have the advanced analytics unit. It's the unit where I'm working on. It's a data science part. And then, of course, we have a data office. So they are involved in all the data governance actions. So just putting a context to all of it. So who are we and what we do at the Advanced Analytics unit of Mango? So basically, our mission is to give support to the company's decision-making process. What we do is help Mango become a data-driven organization, and we try to improve the company's results through machine learning and, of course, all kind of not only machine learning, but all kind of artificial intelligence actions. The team is led by the CDO, Juan, and we have a brilliant head of data science, which is David. And then we are to the different area. We're focused on prices. Then we have also the customer path with Paul and Ilan. And then, of course, we have a team of engineering led by Luis and Riol that they are giving us support in terms of big data. As I was saying before, we have a data warehouse platform where we store all of our data. It's a Teradata warehouse where all the reporting and dashboarding and all the classical actions have been, based on. And now these days we have built, and we are already using a big data platform built on Amazon Web Services, AWS, and Databricks, where all the advanced projects and all the, we call it robots, so basically all the artificial intelligence actions are based on. So, retail. You cannot imagine how much data we have, right? Because we have information from the sales, we have information from the transactions. So we have more than 2,000 stores worldwide. So that's a lot of transactions, direct transactions, all the purchases, all the information of the shops, all the stocks that we have. But then we have also other inputs, right? Like all the information from the customer, the clients, the campaigns, all the click stream. We also have recommendations. We also have size suggestions. There's a lot of things that comes from different origins. The geoanalytics, we have sensorizations, RFID, all the logistics. That's a ton. So where should we start? Where should we invest our efforts and money in doing data science projects? I strongly believe that there are 3 points that every single data science project should have. The first one, it should be actionable, it should be measurable, second, and then it should have a real and clear impact. Because it's really, really important that you put your focus and your effort on action that really give you value and confidence from business. My point here is start small, prove your value, and then continue growing. Do not start with a very big project because you will get lost in the details and you will lose the business attention in the meantime. That's where the first project we developed and the most important one of our unit comes into play. Let me introduce you to Miles, which is a project that we started to find which is the optimal price to maximize project after outlet for each product of our collection. So basically the question that we would like to answer is, which is the optimal discount? The project was actionable because all the variable and costs of the production process were available. It was measurable because we designed A/B testing to be able to measure the success of the project, and it has a clear impact. It has increased the mean profitability during sales season. So it's not only that we have put all the efforts into this project because it's because we can get profit. The impact is not only money. What is the real impact of this project? The first one, of course, the business, because we were considering all the information and we are able to find the optimal price, and that's means more revenue. But then it's a support. We give support and tools to the business to take informed decisions. We try to create a product. We are actually creating a product to the business to be more autonomous on the decisions. And it builds knowledge. It creates knowledge to make more actions, to spread the word that we are able to do more things. So we start small, we show the value, and then we continue to grow from there. What are the parts that this project is based on? First of all, we start understand all your variables before you start to do the machine learning algorithms. Why is that? Because you need to understand the variables. You need to select the right input for your model. You cannot start with all the variables and just start testing things, because you will get lost in the details. You will miss something. You need to understand your data. For instance, we selected which were the right input and what were the variable importance of all the variables that we had. It was a lot of them, like recent purchases, like stocks, like the price elasticity. We did a lot of testing there. Shops, we tested all the variables and we saw which one, and then we take actions from there. Like this one, to build the machine learning algorithm. We train to predict the product sales for each week of the sales season. Actually, we tested give you so it's complex enough. But although trees are not the most interpretable models of all, you can understand what's going on behind them. So it's really, really important you understand your model and you understand what's going on every time. And then once we have our model trained, we created an optimization to find which is the optimal price. I have simplified a lot. The process is a bit complicated and I have simplified a lot. So I'm going to try to put an example here. Basically, what we do is to create a vast matrix with all the possible price points for each week and product. And we give a forecast sale prediction for each one of these. So if you had a forecast prediction and a price, you can calculate the margin after outlet and then just rank that and find which one is the optimal price. As I've said, this is a very, very simple example that I'm going to put. It's not the actual one, so it's way more complicated, but just to make sure that you see how we do things. Basically, we create this matrix with an ID for each price point, and then we put all the possible price points every item can have every week. So the first row will be, for instance, $4.99, all of them. The second row will be all $4.99 except the first one, that will be $5.99. The third row will be $4.99 for all weeks except the first 2 weeks that we have $5.99, and so on, right? And then we create this huge matrix. This is, as I've said, this is not the real data. This is something that I have just made up just to show an example. And we create this matrix with all the possible combinations and predicted sales. For instance, for model A, in the first week, we can choose between $6.99 and $3.99. And thanks to our machine learning algorithm, we obtain a prediction. We obtain a forecast of the sales that we're going to have for this week at this price. In the first case, if we put $6.99 as the price of the first week, we will sell 5 units. If we put $3.99, we will sell 10 units. What is better? To sell less but a more expensive price, or to sell more, a more cheap price? So it's a balance between the two. You just need to find where the optimum is. Basically, we do that for every possible price point, for every possible week. And we obtain something like a matrix of around 30 million rows for 20 variables. So it's around 1 gigabyte for each simulation, for each scenario. Of course, this starts to grow in complexity when you have different scenarios per country, different lines, different divisions. You've got different countries. So, you can see how big this can be, right? Then the measurable part. It is mandatory that all the projects that you do, you showcase the impact, you showcase the result. So you need to measure. To do that, we have designed and developed an A/B test. Basically, we have defined different areas, different zones of the map, and we have also defined different parts of our collection. We have divided the collection, and we have done what is called difference of differences. So basically, you in one part, in one sample, you apply the new method, the new algorithm, so Midas in this case, and on another part, on an area, on another sample, you apply the legacy method. The legacy method was to put the prices in a more manual way. So you can compare the results between zones and between families, parts of your collection. So basically, this is an example of data. This is not real data. When you apply the difference of differences, for instance, you can calculate the rate. So B minus R in this case would be 3. You can tell, of course, that B minus R is, of course, simulated data. To find which is the profitability of Midas. In another part of the collection, you can test the same. So C minus C in this case will be 0. There will be no difference. But you have a group of control, so you can tell what is the intrinsic difference between areas. So in this example here, the mean profitability between zones, between areas, it's -2. So you can tell here that the actual impact of Midas by family, in the case of families A, will be 1%, so with 3 minus 2, and in the case of families B, will be 0 plus 2. So if you do the mean impact, you will have, for instance, in this case, 1.5 profitability of Midas. So you're actually measuring what is the real impact of your project. You can give a number, and that's very important to give confidence and value, but also, so when you bring the impact to the stakeholders, you showcase the results, you showcase the impact, but also you need to measure to understand the dynamics of the actions that has taken. For instance, measuring has helped us to actually understand the consumer behavior, to actually understand how what are the pros and cons of Midas, and how can we improve the product? How can we develop new actions to make the product? Once you have actioned the project, once you have obtained a significant impact, what's next? So you need to scale that. How actually are you going to scale something? You need to put the project on production. You need to create a product from a POC, from a proof of concept, or from whatever it was the first test of your project. And you need to assure that you bring value and quality. And for that, I think there are 5 points that are key into any model you bring into production. It has to be automated. It has to be very robust. It has to be operational. People have to use it. If not, it's meaningless. It has to be reliable, and it has to be scalable. You want to attack the long tail. You want to attack all the possible scenarios that you have tested. You want to, grow and get big. And here goes a few tips that I have, we have learned as a team over the past years, and I think it's very important to keep in mind. The first one about the code: be prepared for the future. You need to be very flexible, because there will be a lot of changes that has to be made, and if you do something without parameterizations and so on, you will blame yourself in the future. It has to be scalable, 100%. Maybe you don't see it now, but you will have to scale it for sure. Please be documented, because you're not alone in the world. And at some point, maybe now you're working alone, but in the future, there will be a team with you. So please document everything and be organized. That is why tools like Git or Bitbucket exist. So please use a control version, because it will really help you in the future. R&D. So interpretability is really key. Don't focus on precision, but on getting the job done. And do not misunderstand me here. I'm not saying that accuracy is not important. It is, but it's not worth it to spend 2 weeks or 1 month, for instance, just trying to obtain a 1% increase in accuracy. What it's really important is that you understand your model and you get the prediction, you are able to interpret them. At every point, it doesn't matter if you're logistic regression or if you're just be aware of them and you are able to explain them. And if you're not sure if your results are understandable, use the grammar principle. The grammar principle is something that Albert Einstein said once, that it's you do not unless you ask your grammar. If you doubt, if you was going to say, just visit your grandma, but nowadays in these times, just call her, do a video call with her, and ask her. Just explain your project to her, and if she understands it, if she likes it, you're on the good path. You're doing things right. So just make sure that a team. That's the most fundamental things of all. A solo mission, side mission, diverse in terms of gender, terms of background, and terms of experience too. I know we all tend to do the same. We tend to surround ourselves with people similar to us. But when you have a problem, when you're facing a problem, different background, different experiences, even different genders, attack the problem in different ways. We all think different. So that's very important, because a diverse team will be able to solve a problem way more easy and way more fast than a team of very similar profiles. Also, data science is a huge field right now, right? You can know a lot of things, but you don't have to know everything. So just make sure that if you're a data scientist and you know about models, do not try to build infrastructure yourself. Do not try to create yourself your ETLs and so on, because it's too much. Just get the right team. Get good engineers to help you with infrastructure. And also be really aware of your needs. There is a huge big data ecosystem right now. There's like different million tools on the market that helps you do the same. Just make sure that the products and the tools that you're using are the ones that you really need, because maybe you're using something that it's not right for you. Not because something is trendy and fancy, you have to use it. There are a lot of fancy words right now in big data. There are more tools in big data than Pokemons. So just make sure that you know what are the tools that you really need. Just to sum up a little bit, this is a quote from Daniel Keyes that I really love. You can have data without information, but you cannot have information without data. Everyone has data nowadays. Just make sure that you're able to extract information from it. Just as the final remarks, We need to take informed decisions because knowledge is key. There are a lot of opportunities to assist on the business decision making on every organization at any level. There are a lot of tons of room for growth and to develop R&D tools, but it's really important to make sure that your data science projects are actionable, measurable, and have an impact, because otherwise you will not succeed on the long run. Thank you so much. I really appreciate that you've been here with us today. I hope this talk will give you some light and helps you in any way. I will be very happy to answer any of the questions you have right now. And if you like to stay in contact or make any comments, just ping me at carmen.herrero@mango.com. Thank you so much.
Okay, if someone has a question or a comment, you can use the YouTube channel. But while you are writing, just thank you, Carmen, very much. It was a great talk. Well, I promised you it would be a very interesting talk, so I think she delivered. And well, while some people could be thinking about their questions, I'd like to ask you something, Carmen.
Yeah, go ahead.
When you face a new challenge like the huge one you presented, this model to predict the optimal prices for the clothes, how do you decide where to begin and which algorithms to use, how to measure your performance? How do you face the project?
So that's a very interesting question, right? That's the key of all. Normally, what happens is a business comes with you to you with a problem, right? So I need to solve this problem, and then it's your job to just understand what they really need and create this project just to make sure that you have a clear question on bottom part. On it, you put time, and you also have to think, of course, and on the measure part and so on. The whole thing is that you need to be really sure that you have all the parts together before starting the project. I'm not quite sure if I have answered your question.
Yes, it was a bit. We had a bit of cuts in your words, but I think that the main message was there, and in fact, I think that we would agree in saying that preparing the project and facing it is one of the most important parts of the whole machine learning journey, because if you start with the wrong foot, then it's worse at the end. Okay, since we don't have more questions, we just have very nice words from the audience. So thank you very much, Carmen. And I will talk now and do my presentation. Okay, well, let me introduce myself again. I'm Didac Fortuny, data scientist in the machine learning team of InfoJobs in Adevinta. And I will talk about a solution that we built with deep learning to improve the matchmaking in InfoJobs. But before I start, I would like to make sure that everyone understands what I will talk about. So let's have a look at the title of the talk. First, everyone knows what is matchmaking. I cannot see you, but I can guess that some of you maybe doesn't. So let's clarify. What do you mean? What do I mean by matchmaking? We in Adevinta know a lot about matchmaking. Matchmaking is finding the best house for each family in Fotocasa Boitaclia, find the best or finding the best. In InfoJobs, matchmaking is finding the best candidate for each company who is looking for professionals, or finding the best job for each person who is seeking a job. So this is what we mean by matchmaking, connecting people who have the same goal. And the other part, the other important part of the title was deep learning. I don't know if all of you know what is deep learning. Just clarify, this is not the reason I had the goggles in to go deeper. But if we talk about artificial intelligence, artificial intelligence is a broad field. Machine learning, when we talk about machine learning, what Carmen just explained to us, it's a subfield of artificial intelligence. And then when we talk about deep learning, it's some sort of algorithms within the machine learning algorithms. Some algorithms are classified as deep learning because mainly they consist on neural networks, and in particular in deep neural networks. This is a very broad definition. I'm sure that it's not the correct one, but just to give you an idea about what I will talk about, I will talk about some algorithms, machine learning algorithms that consist on deep neural networks. So my talk will consist of 4 parts. First, I will give you a bit of background to show you what is InfoJobs and the problems we had. Then how we approach these problems, a bit like the question I asked to Carmen before, how we decided to tackle the problem. And then I will go to the core of the talk, that it's all the normalization workflow, how we build the solution to normalize the job title, the job title field in InfoJobs. And at the end, to prove that our solution has value, I will show you some use cases of it. Okay, I'm sure most of you know what it is InfoJobs, but in case you don't, InfoJobs is the main job portal in Spain, and mainly we have to target two groups of people who are using InfoJobs. First, employers who publish offers looking for professionals, and then job seekers who publish their resumes with their list of experiences, of past experiences that are looking for a job. When looking for the pains of our users, what they were worried about when using our platform, we detected that one of the main pains was like this. For example, this man here, who is a recruiter, was struggling because he was looking for a Python developer. And even though in InfoJobs we have plenty of people who can work as Python developers, all of these persons here are can code in Python. We have plenty of people who can work as Python developer, but because they didn't write the exact words Python developer in their resumes, we couldn't find them easily. For example, the first man he knows Python, and I'm sure that he could work as a Python developer, but he doesn't write the word developer anywhere. Or the girl below she's a developer, and we know, looking at their skills, that she can work, she can code in Python, but the Python developer thing was not there, so it was not easy to find. And we also had the inverse problem. We had some people like this girl here, who was in fact a Python developer, and she couldn't find a job even though she was using InfoJobs. And in InfoJobs, we have plenty of offers who are looking for Python developers. We have plenty of companies who are looking for this kind of professionals, and offers related with them. But again, because they didn't use the same language, we couldn't connect them easily. So when looking at this problem, we draw this conclusion, this hypothesis. If we are able to normalize the job title field of offers and resumes, and by job title field, I mean the profession or the type of offer you are looking for, your profession, your job title. If we are able to normalize it, we could improve the experience of both the employers and the candidates. And again, to clarify the terms, what I mean by normalizing. For us, normalizing means this. Given a closed list of job title categories, what we call a taxonomy, for example, this one, we have here a list of 2,000 and more job title categories. Construction laborer, adult literacy teacher, and so on. Given this list of job title classes, categories, being able to tell that each experience or each offer belongs to which of the categories. So classifying, having into account the whole corpus of the offer and the whole corpus of the experience to classify it into one of the categories. If we are able to do this, we can connect them more easily. So we decided to use machine learning, and in particular deep learning, to solve this problem and to build a model that, again, what the model would do is to take any job offer or any resume entry and classify it into one of the categories and giving a confidence score to know how much we can trust this prediction. For example, having this guy here and being able to predict that he belongs to the class 1263, that is the one containing the Python developers with high confidence, or this offer here, the same. This was our approach. To build a machine learning problem, the first thing you need is ground truth, or at least to solve any what is called supervised machine learning problem is to build a ground truth. A ground truth is nothing more than a list of labeled examples. For example, to tell a model to differentiate the offers between this list of 3,000 categories, we need to provide the model some examples of each of the categories. This way, the model will learn patterns that makes it able to then later classify some examples that the model has not seen before. To do this, first we need the taxonomy. The taxonomy is the list of classes to which we want to classify. And in our case, we used ESCO. ESCO is an European database of job titles. And we use this because, first, it contains job title hierarchy. It means that we know how different job titles are connected. So this is useful for other reasons that I will not explain now, but we don't have only a list of categories, but we also have relations between them. Also, it's huge. It has around 3,000 occupations. And also, it's an European standard. And this means that, first, it's available in several languages. This is useful because this is crucial, in fact, because in InfoJobs, our web page is in Spanish, but some people write their resumes in English. And we also have InfoJobs in Italy, so we want to build a model that can be adapted to work in Italian. For us, having all these translations directly, free, it's crucial. Also, it's well maintained. If new job titles appear, for example, I can say that maybe in 5 years, a YouTuber or influencer would be a job title. This ESCO, we believe that ESCO will catch these new job titles, so it's maintained for a third party. It's also good for us. And then it contains a lot of synonyms. This is very useful, as I will explain to you later. So to give you a snapshot about how our taxonomy looks like, it's fake, but it looks like something like this. We would have the first class, the construction laborer class, having these synonyms. We know that job title is construction laborer, but you also can call a person who is working as a construction laborer, construction worker, or in other languages, obrero de la construcción, obrera de la construcción. We also have the male and the female form for the languages that have a male and female form. And this, we have about 3,000 categories. And counting all the synonyms, we have about 50,000 different job titles. Okay, we have the 3,000 categories, but we need to find examples for each of them. One thing that we could do is to hire a person to look for all the offers in our database and tell, okay, this is for category 1, this is for category 2, this is for category 3081. But having to look at 3,000 categories each time, it's not an easy task, and it would lead to a lot of problems. So we decided to face the problem in a more smart way. The first thing we did was all the people who wrote something in their job title field of their resumes that is exactly one of the synonyms of our taxonomy, we labeled it automatically. So this was free. The first guy in the top right of the screen, he wrote Administrador de Perros Guía, and Administrador de Perros Guía, we see that it's a synonym of the category 4. So it's automatically labeled. The construction laborer, the offer that it's looking for a construction laborer also can automatically be labeled to the class 1. With this, we have a ground truth, a preliminary ground truth. This is not the best ground truth because we are like cheating a bit, but it allows us to train a preliminary classifier model. It's not the best model, but we have something. Once we had this preliminary classifier model, what we did is perform predictions for unseen data for all for a lot of offers and resumes that didn't have a job title field matching directly to one of the synonyms of our taxonomy. We made a prediction, and then this time we hired someone to label whether these predictions were correct or not. But it's not the same to say, okay, this prediction is correct or not, that telling that having to choose between 3,000 categories for each offer or experience. So with this, we were able to expand our ground truth with more rich examples. And with this, we were able at the end to train our final classifier model. 1 second. Okay. Now let's talk about the model itself, which algorithm we used. Why I'm talking about deep learning, I still haven't showed you any neural network. And I will not show you yet, but just it's, I'm about to do it. The classifier model that we designed, it's based on a method called transfer learning. Transfer learning is nothing more than using the knowledge you gain for solving one problem to solve a different but related problem. For example, when you are at school and you learned how to write compositions, you then don't use this. When you are an adult, you don't use this knowledge to write compositions. We don't write compositions anymore. We use the knowledge we learned by writing compositions to solve other tasks like writing books, writing emails, writing letters. We transfer the learning. This is what is called, this is the idea behind transfer learning. And in particular, in deep learning, transfer learning has been used a lot in computer vision. For example, if you have here this girl in the picture and you want to create a model that is able to tell whether the girl is a female or a male, you would build a convolutional neural network. If you look, like in the one in the image below, if you look at the layers inside the convolutional neural network, you would see that the first layers are able to find very simple patterns like shapes, borders, shades. When you go deeper in the net, the layers are starting to recognize more complex patterns like eyes, noses, mouths, and these more complex structures. And at the end, the deepest layers will start showing faces and complex patterns. And then when you have this, at the end, you just need to insert some classifier layers to take these faces and classify between female and male. Now imagine that I want to create another model to tell which of these 5 people in the left, in the right, is the girl in the picture. The idea here is that I don't need to train a new model from scratch, consuming a lot of time, a lot of energy, and needing lots and lots of images to train a new model from scratch. The only thing I need to do, what I can do is take everything inside the orange box and reuse it. This is a model that is able to detect faces, though. So why don't use this face detector and just change the last part? So this is the idea behind transfer learning. What we need to do is first train a little bit the neural network further, because if we want to separate images between these 5 persons in the left, in the right, you need to show images of these people to the model in order because the model has to know how to find the difference between them. So first train further with more examples of the new classes, and then change the final classifier layers, because it's not the same to classify between 2 classes than classifying between 5 classes. This is the only thing you need to do. It's much faster than creating a new model from scratch. Okay, in natural language processing, when dealing with text, not images, how we use transfer learning. The idea is quite similar. We begin with a general language model. That a general language model is nothing more than a model that predicts the next word in a sequence. And it is trained using large corpuses of text like Wikipedia or other sources of text that exist online. You can train your own language model, or you can use language models that are available for the community. You can download them and use them. This is something that it's free for the community. Then we want the model to not just know how to deal with Wikipedia articles, but we want to teach the model how to deal with job-related text. So we train a little bit further using text extracted from InfoJobs, from resumes and from offers. Then the model is able to adapt a bit to our vocabulary. And once we have this fine-tuned language model for InfoJobs, we'll have like the face detector that I was commenting before. Now we can use this InfoJobs language model for a lot of things. One of the things that we have used it is for the normalizing model that I was explaining. So at the end, we change the last part of the model. We don't want to predict the next word anymore, but we want to classify between the 3,000 classes. So the last part of the model, the last layers of the neural network, what does is take everything that enters, the offer, the description, everything inside the offer or the job title experience, and guess the probability of belonging to each of the classes. And with this, we have already our classifier. If you want to know more about the architecture of the neural network, it consists of, well, we have a vocabulary size of 60,000 words with embedding of 400 dimensions, and then we have three LSTM layers. And at the end, the classifier part consists of 3 more layers with these dimensions written here. And everything we have programmed it using FastAI, that it's a library, a deep learning library for Python that it's built over PyTorch because it's fast in experimenting and prototyping. Also, it's easy to implement because all the classes are already there and you can start using them. And also, they include the state-of-the-art NLP when new techniques appear or become popular. They include it in the library, so it's very useful. And once we have the model, how we put this into production, how we start normalizing everything. This part here, I am not an expert in this part here. In our team are a mix of data scientists and backend developers, and the ones that put everything into production are the backend developers. But I will give you a brief idea about how the system is. is how the system is. First, each time a new entry, a new offer or resume enters our system, or an old one is modified, an event is sent to Kafka, that it's a queue manager, some sort of queue manager. Then the normalization microservice listens to this event and sends another event to the classifier model microservice, that is the one containing the neural network, the model. Then the normalization is made, is returned to the normalization microservice, and this publishes another event into Kafka. And then all the services interested in consuming the normalizations are listening and can use them. For example, the data warehouse stores all the normalizations, but other products also make use of this normalization. Everything is programmed in Java, following the Netflix stack, but the classifier model microservice, because the model is in Python, so this microservice is a hybrid model microservice, both using Java and Python at the same time. And finally, we have our model and it is in production, but how we know that the model works? We can trust the model. I will show you an example of how we guess the accuracy or the performance of the model. Now imagine that we have this girl here she considers herself a confitera. She writes confitera in the job title field, in her job title field. And our model classifies her profile into the category 23. That is the one here in the right. Because confitera is one of the synonyms of the class to which the entry has been normalized, we can guess that it's a good prediction. Now imagine that this offer here is looking for cocinero. The model classifies this offer into the first class again, but cocinero is not one of the synonyms of the first class, and it's a synonym of another class, the class 324. So this is a wrong prediction because the model should have classified this offer into the 324 category. This is wrong. What happens if someone writes something that is not a synonym of any of the categories? This cake master here has been classified to the pastry chef class, but cake master doesn't appear in the taxonomy. Then we don't know. We don't know if this prediction is correct or not. What we do is we take all the ones that we know that are correct or we know that are false, and with this we estimate the performance of our model. It's not a perfect estimation because we are missing plenty of things that we don't know if they are correct or not, but this gives an idea about how the model is performing. And to go a bit deeper in this, we have a dashboard. And this dashboard tells us for each category how many correct predictions are, how many wrong predictions are. And with this, we can focus on those categories that have a lot of wrong categories. With the dashboard, we can go deeper and see what things has been normalized to what, and explore and improve the model with this feedback that the dashboard is giving to us. And the other way around, we can also see what is the people writing in their job title field and see to which categories has been normalized and see whether it makes sense or not. With this, we also would detect whether new job titles appear. For example, the influencer I was talking to you about before, if people start to write influencer and this is normalized to nonsense categories, we would detect it and we could add influencer to our taxonomy. Having this, we guess that more than 90% of job titles in our database are normalized with high confidence, and we are very happy with this. Because, well, later I will explain the use cases and you will see the value of this. To sum up the normalization workflow, as I told you, we build a ground truth. Then we train a classifier model. We test whether the model is better than the one that we had in production before. If it is, we put the model into production, and with the dashboard, we check the performance and we see the weak points of the model in production. When we have enough feedback, we create another ground truth and we train another model, and this cycle is improving the model all the time. What happens if the new model is worse, that perform worse than the one that is already in production? When this happens, we have to add more ground truth or check whether if we can find a new architecture that is able to beat the one that we were using before. But we don't put the new model into production until we make sure that it is not better than the one we had before. And to end up and to prove that this has added value to InfoJobs, I will present some use cases. First, if you are looking for a job and you enter InfoJobs, you enter an offer and you will have a percentage of matching. It will say to you, you match 75%, for example. How this percentage is calculated? Before the normalization, we couldn't compare experiences and offers because they were all only open fields that we couldn't compare whether they were equal or not. With normalizations, not only job offers, we have job titles, we have normalized lots of other fields. With normalizations, now offers and experiences talk the same language, so we can check whether they match. You have the skills that the job offer is requiring or not, so we can show you this match. This has been very useful because now the users that see a high percentage apply more, and the ones that see a low percentage apply less. And this is very good because people don't have to lose time with processes that will not end well, and companies doesn't receive too much resumes that cannot afford. They only receive those that are the more interesting ones. So this has proved value. Another example is the search engine of InfoJobs. Before that, if you looked, for example, before normalizations, if you look for Agile Coach, you would only get results containing the words Agile Coach, like a normal search engine. Now, because we have in our taxonomy Agile Coach and Scrum Master as synonyms, and everything in Agile Coach and Scrum Master are normalized to the same category, when you look for Agile Coach, you will get everything that has been normalized to that category, containing all the synonyms. This means that with only one search, you will get all the relevant results, and you don't have to search for all the ways your job can be written, and also all the languages and so on. Another interesting thing here is now if you look for something in the female form, because we are using normalizations, you will get all the offers, not only those that has thought that they have to write also the female form in the job offer description. And finally, this is a very recent use case. These days, InfoJobs has been sending at 8 o'clock notifications to all the users that work in the health sector to thank them for their work these days. And how did we find which users were working in the health sector? Because we have everyone normalized, we can select the job titles that belong to the health sector and send a notification to all the people who has an experience normalized to these categories. This is just to end, and the final message here is that if you build a powerful project and a powerful tool like the normalization, you never know how it will be used, but for sure it will be used for interesting purposes in the future. That's all I wanted to tell you. So now if you have any questions you can ask them in the comments section, and I will be happy to answer them. Also, Okay, someone is asking which model we used as a starting point for transfer learning. In fact, we built our own language model. We trained a language model using Wikipedia. And so we didn't reuse anything that was done before. The transfer learning here is that most part of what we did, training a language model from scratch using Wikipedia, and then fine-tuning it with InfoJobs data, all this process that we did can be used for another problems. So this is the point here is that we didn't benefit of models trained for other people, but the model that we already trained will be useful for so a lot of other projects. Okay, another question is if you use the model to help people to create better descriptions or profiles. We don't yet. This is clearly something that we have in mind to being able to somehow give feedback when the people is writing descriptions in InfoJobs and guide them into telling them whether the description or what they are introducing is good or not, but we are not at that point yet, so we haven't done it. Another question, if it's open source, at the moment it is not. What we have done is not open source, but FastAI, the library we used, it is open source. So if you look for documentation in FastAI, you can easily find a way of doing your own model using that library. Okay, for me or for Carmen, well, I haven't not talked with her about this, but if you have further questions later, you can look for us in LinkedIn or whatever, and you can send us questions anytime. And well, it's getting late, so I think that we can move to the last part of the talk that Xavi Roca here will introduce you Data for Good Barcelona, what we are doing, and I'm sure that you will find it very interesting and enriching, and I hope you do. Xavi?
Thanks, Didac. Okay. Hello, everyone. First of all, I want to thank Adevinta for inviting us to this interesting meetup and giving us the opportunity to share our project. I will present myself also. I'm Xavi Ros. I work as a data researcher for a traffic software company. And I invest my free time on Data for Good Barcelona, which is an initiative where Didac is also involved. And he invited us in. And thanks. Okay. I am going to explain you very fast which are our objectives and what we do to accomplish them. First of all, we are a young non-profit association in Barcelona that, as volunteers, want to promote the use of data by social entities or for positive impact projects. Yes, this is not new in the world. We are based on other communities that were born in UK and in France, DataKind and Data for Good France. And that years from now, they started to plan projects with social entities, and nowadays they are very big and they lead big projects with social entities, and also they plan hackathons to generate this positive impact that we are looking for. 2 years from now, we started by organizing a meetup in Barcelona, and we had a very interesting reception by the data community of Barcelona, which, as you know, is very big. So we decided to create an association and start working to promote this initiative. And moreover, we are very proud that 2 months ago, we helped a group of people to set up this same initiative in Madrid. So we encourage anyone that is listening to us from other cities in Spain or maybe in Europe that if they want to set up this initiative also in their cities, please contact or Didac or me or our data for good email that I will show you later on. Okay, what we do? We act mainly in 5 pillars that we identified one day and we want to share with you. First of all, we connect data scientists with social entities. That image is using video because of the current lockdown, but we also go to these social entities and we meet them there and we know their problematics and we try to generate these possible synergies. We also want to inspire the data scientist communities with positive impact projects, organizing our meetups. We do meetups every three months, more or less. We also want to spread the value of exploiting data to these social entities. For this, we are writing some articles with M4Social, which is a big entity that tries to converse these social entities and to promote the technology into them. And also we also empower them by teaching some basic data science to them, to their statistics, to the statisticians. And finally, we also conduct projects with them and volunteers that we look for, and we do the project management of these projects with their data to solve some problems that they have. Our community grows day by day, but we are proud to show our numbers today, and we are very proud of them because we think that in 2 years we did a great initiative here in Barcelona. We are nowadays 8 co-founders and board members. We also have more than 1,000 followers in Meetup. We have 337 subscribers in the newsletter, almost 500 followers in Twitter, and 27 volunteers working right now in our projects with the social entities. Nowadays, we are working in 8 projects. There are more or less 4 that will come after this lockdown if we can overpass this annoying situation. And from the very beginning, we were working or contacting more than 20 entities, social entities in Barcelona. Okay, this is the end of my presentation. These are the ways to contact us. Please do it if you find it interesting. And okay, just to remember, we also have a newsletter. Please subscribe with this bit.ly link. In our social media and newsletter, we post very interesting projects in data science and jobs and volunteering offers for good. And of course, again, if you want to contact us in a more personal way, you have Didac and you have myself to contact us via LinkedIn or something. Thank you very much for this opportunity.
Okay, thank you, Xavi, for presenting Data for Good. You did a great job, and just everyone can take note of these ways of contacting us. Yeah, otherwise you can look us in Google and you will find us. And just to close, thank you very much, Xavi. Thank you, Carmen, for your talks and your contributions. It has been a great evening. Now we would have pizzas, but I'm afraid it will not be possible, at least for me. I hope you have a few home. And a final message, please. You will find a survey in the LinkedIn channel. If you fill the survey, it will be great because it will make us to improve. Thank you very much for attending, and that's all. Good evening.
Thank you so much. Bye.